Welcome to our topic on Clinical Laboratory Test Quick Guide on how to meet accreditation requirements. We are going to check on mandatory test components, which are validation, SOP or procedure manual, quality control, proficiency testing, staff training, competency assessment, maintenance of equipment, and reagent control. The first mandatory test component is proficiency testing. Proficiency testing is also called interlaboratory comparison and is a form of external quality assurance. It involves analyzing results of same samples obtained by different laboratories. Proficiency testing performance and assessment are major elements of a laboratory's quality assurance (QA) program. By reviewing the laboratory's PT results with participant summaries, the laboratory can assess their ability to maintain the accuracy and reliability of its test results. For those analytes (non-regulated analytes) which are not included in a formal proficiency testing program, the laboratory must provide a method to assess and verify the accuracy and reliability of their analytes by performing alternative proficiency assessment. The second one is validation or verification. Unless a test is laboratory developed, validation is normally done by the manufacturer. Thus, labs will be performing verification studies. This is done to determine or verify the performance of the test and its reproducibility within the patient population. By conducting a validation or verification study, a lab will check for predetermined acceptability criteria which must be met. Depending on whether a test is quantitative or qualitative, the study may include a study of precision, accuracy, sensitivity, specificity, reference interval, detection limit, recovery, linearity, interferences, and reportable range. The third one is standard operating procedures or procedure manuals. All tests performed in the lab must have procedure manual or SOP. They must be approved before use, clear, consistent, and controlled. They must be available near the area where testing is done for quick reference when needed. All procedure manuals or SOPs must have the following clauses where applicable. 1. Principal and clinical significance. 2. Requirements for patient preparation, specimen collection, labeling, storage, preservation, transportation, processing, and referral, and criteria for specimen acceptability and rejection. 3. Step-by-step performance of the procedure, including test calculations and interpretations of results. 4. Preparation of solutions, calibrators, controls, reagents, stains, and other material used in testing. 5. Calibration and calibration verification procedures. 6. The analytic measurement range for the test results for the test system, if applicable. 7. Control procedures and corrective action to take when calibration or control results fail to meet the laboratory's criteria for acceptability. 8. Limitations in the test methodology, including interfering substances. 9. Reference intervals. 10. Imminently life-threatening, that is, critical or panic test results. 11. Pertinent literature references. And the last one, appendices or related documents or forms or charts. The fourth one is quality control. Quality control, that is QC, consists of analyzing specimens of known concentration, carefully recording and interpreting these values before releasing subject results. Quality control is performed in the laboratory to ensure that accuracy and precision are maintained in the performance of laboratory analysis each day. There must be an ongoing daily quality control program with established internal review procedure. The quality control program can be divided into the following main areas of focus. 1. Internal quality control, that is, testing of known materials. 2. Parallel testing, that is, validation of new controls and reagent lots. 3. Blind or split sample testing. 4. Proficiency, that is, external testing programs. 5. Quality control monitoring, that is, corrective action logs. 6. Quality assurance program feedback. And the last one, 7. Quality control through preventative maintenance program. The 5th one is staff training. Every laboratory must establish and define an internal training program to ensure the competency of laboratory personnel. This is to ensure that training has taken place for each employee for procedures and methods that the employee performs. Laboratories should establish an employee qualification or training program. All personnel are classified on the basis of appropriate education, training, skills, and experience. Specific personnel are authorized to perform specific tasks. Records of all training activities are kept in each employee's file. The 6th one is competency assessment. Staff competency should be evaluated and reported regularly so that problems may be identified and solved in a timely way. Employees must understand that the goal of competency assessment is to improve performance, hence, improve patient care. Whenever possible, corrective action will not be punitive. Education will be stressed. All 6 elements of competency assessment must be covered during each assessment cycle. 1. Direct observations. 2. Monitoring the recording and reporting of test results. 3. Review of intermediate test results or worksheets. 4. Instrument maintenance and function checks. 5. Blind testing samples or external proficiency testing samples. The last one, 6th, evaluation of problem-solving skills. The 7th one is equipment maintenance. Maintenance is one of the visible aspects of good equipment asset management. It is a service that aims to ensure equipment function. When maintenance is not done or it is delayed for too long, the risk to continued operation rises rapidly because of the increasing likelihood of parts failure. Prepare the maintenance schedules for all equipment items. The schedule is to include 1. Preventive, 2. Routine, 3. Extra maintenance, 4. Cleaning and sanitation, 5. Corrective maintenance. The last mandatory test component is reagent control. Clinical laboratory reagents and control materials are exposed to many variables due to conditions during transportation and storage environments in different laboratory settings. The lab must develop a program to manage reagents so that these variables do not negatively impact patients' results. The program ensures validation of new reagent kits with old reagent kits with aim of ensuring that in spite of varying environmental conditions, there are no clinically significant differences in the results obtained when different lot numbers of reagents are used.